Hello. In this video we will discuss about two-dimensional heat equation. In my previous video we have to see about separation of variable, method of separation of variable to solve partial differential equation, one-dimensional heat equation, two-dimensional wave equation. टू डायमेंशनल के केस में हमने स्टडी नहीं किया है. So in this video we will discuss about two-dimensional heat equation. To think about this, we will take an example to consider it. Question is a thin rectangular plate whose surface is impervious to heat flow has T equal to 0 and arbitrary distribution of temperature fxy. Its four edges x equal to 0, x equal to a, y equal to 0, y equal to b are kept at zero temperature. Determine the temperature at a point of the plate as T increases. So consider this question. Question is a thin rectangular plate whose surface is impervious to heat flow at T equal to 0. An arbitrary distribution of temperature is given by Fxy. Its four edges x equal to 0, x equal to a, y equal to b, y equal to 0, y equal to b are kept at 0 temperature. Determine the temperature at a point of the plate as T increases. So when we discuss in one-dimensional heat flow, we see that there is a rod. A rod is the case of one-dimensional heat flow. When we consider a rod, it behaves in a geometry like x-axis or y-axis. This can be represented in x-axis or y-axis. A rod is represent one-dimensional flow. While in this question we taken a plate, and we well known that when we consider a plane, that is the two-dimensional case, and this two-dimensional case will be a rectangular, a square, or in any other shape, or it will be circle, or it will be hyperbola, or it will be ellipse, whichever. Just we consider a plane. So in this question we have a rectangular plate. It means we have a surface rectangular plate like this. This is x-axis, this is y-axis. Along x-axis it will be A, along y-axis it will be B. So this is a structure. So when we consider in rectangular plate, and in this plate we transfer the heat change. So the partial differential equation of two-dimensional heat conduction problem is del 2u over del x square plus del 2 of u over del y square. This will be 1 upon c square del u over del t. This will be the equation number 1. By this equation, del 2u over del x square plus del 2u over del y square is equal to 1 upon c square del u over del t. This equation can also be written as del u over del t. This will be equal to c square del 2u over del x square plus del 2u over del y square. There is no change in equation 1 and only the it is change of representation. This constant c square in this side or in left hand side. So both the equation are same. Now from this equation 2, it is clear that u is the function of x, y and t. Before this question, all the question which I discussed in my previous videos, in that case u is the function of only two variable x or t, x and t or x and y. But in this question u is the function of x, y and t. That is function of three variable. So there are three independent variable and one dependent variable. U is the dependent variable, x, y and t is the independent variable. So from the question we have, think about this question. It is given that its four edges x equal to 0, x equal to a, y equal to 0, y equal to b are kept at 0 temperature. Yani all the four edges of this rectangle are kept at 0. That is u0 comma y comma t, this will be equal to u a comma y comma t, this will be equal to u x comma 0 comma t, this will be equal to u x comma b comma t. This all the four edges of this rectangular plate is 0. Plate is two-dimensional structure, but when we give the temperature along this will be three-dimensional. So when this is considered the case of plate, so it will be function of two variable x and y. Now it is also given that a thin rectangular plate whose surface is impervious to heat flow has T equal to 0 and arbitrary distribution of temperature fxy. It means and u x comma y comma 0, this is the f of xy. These are total 5 initial condition is given in the question. So now concentrate for this question, how we will solve this type of questions. So process will be same as we discussed in the previous case, but in that cases u is the function of only two variable, but here u is the function of three variable. So let solution of given equation 2 is u is equal to x y t. This will be the equation number 3, where x is function of x only, y is function of y only, t is function of t only. So x, y and t are the function of x only, y only and t only. Now we obtain del 2u over del x square, del 2u over del y square, del u over del t from equation 3 by differentiating equation 3 with partially with respect to x, y and t respectively. And substitute it in equation 2, we have इन इक्वेशन, थोड़ा सा हमको आसानी हो जाएगी इन इक्वेशन 1 में रखना है हम इसको। आसानी सिर्फ ये होगा कि सी स्क्वायर इज द कांस्टेंट, वो एक साथ आएगा, अदरवाइज हमको 2 बार लिखना पड़ेगा। अभी हम इसको क्लियर कर रहे हैं। वाई इंटू टी del 2 of x over del x square, x into t del 2 of y over del y square is equal to x into y upon c square del t over del t. Okay, when we put in this equation we get this. We take this c square in this side, because when we compare by method of separation of variable, when we take c square in this side, we have the solution with respect to x and y both contain the value of c. But when we take it in with respect to t, then it appear only one times. So due to easiness of the solution, we consider like this. Sure. This implies that del 2 of x over del x square x plus del 2 of y over del y square capital Y, this will be equal to del t over c square capital of t del t. This is the equation. Whenever we get relation of the function of two variables, there are only two variables, then x in one side and y in another side. But in this question, since it is the function of three variables, so two function with one side and one function is another side. Two function x and y, because this is for the case of plate. So these the two terms are considered with combined form, and this T will be another side. So it is very important what we should do from this position. So as we discuss in the method of separation of variable, we have the three cases for the substitution. So there are three possibilities of the solution, that is first is 1 upon x del 2 of x over del x square is equal 0, 1 upon y del 2 of y over del y square is 0, and 1 upon c square t del t of t over del t is equal to 0. Second is 1 upon x del 2 of x over del x square is equal to k1 square. Second case is 1 upon y del 2 of y over del y square is equal to k2 of square, क्योंकि दो साइड एक साथ कंसिडर किया जाएगा, एंड 1 upon c square t del t over del t, this be equal to k square. And the third case will be 1 upon x del 2 of x over del x square is equal to minus of k1 square. 1 upon y del 2 of y over del y square is equal to minus of k2 square, and 1 upon c square t del t over del t is equal to k square minus of k square, where since k1, k2 and k, these three terms is also related with the same relation which considered in both the cases, that is where k square is equal to k1 square plus k2 square. क्यों? क्योंकि ये जो इक्वेशन है, आप यहाँ ध्यान दें, this term plus this term is equal to this term. So we have to take the constant. It will be k1, it will be k2, and this will be k. So this k square is equal to k1 square plus k2 square. From all these three cases, which case will be suitable for our case? Since we solve in one-dimensional heat equation, in wave equation, in Laplace equation, we say that our solution will be exist in case of when we take this k is negative. So third case is most appropriate to solve this problem, and rest of the cases will gives trivial solution. So first two cases we will not consider, we consider in case of third only. This I already discussed in my previous videos. Out of these three possibilities, only solution of wave equation, one-dimensional heat equation and Laplace equation will be exist in case of when k will be negative. So out of these three cases, we have to choose that solution which is consistent with the physical nature of the problem. So third case is more suitable. So, on the basis of third case, the solution of x, y and t are given by x, y and t are given by x is equal to c1 cos of k1x plus of c2 sin of k1x. Y is equal to c3 cos of k2x, c4 cos of k2x and t c5 e to power minus of c square k square k square t. So the complete solution of given partial differential equation is u of x comma y comma t, this will be equal to c1 cos of k1x, c2 sin of k1x, this will be y, क्योंकि this will be solved with respect to the variable y, into c3 cos of k2y plus c4 sin of k2y into c5 e to power minus c square k square t. This is the solution of given partial differential equation 1. This one. This is the solution. And this will be the equation number 4. This will be the equation number 4. So, one thing is very important, that this condition is very important. When we solve this type of question, we have to see about this equation. In this part, we have considered this part is directly k minus k square. So this will be also minus k square and this will be minus k square. But this k square will be with the both sides. So it will be the combination of two terms. And so we have to take in this k square is minus k1 square plus k2 square. So this is the very important, this is the very focused point. This is the change in rest of the my discussion in the previous videos. This part is the different from rest of the cases. So be careful whenever you write this part. This is the focused part in this case, in this problem. Now we obtain the given solution. We obtain the solution of the given partial differential equation. But this solution consists of 5 unknown constants C1, C2, C3, C4 and C5, and also the value of K1, K2 are unknown. K1, K2 are unknown. So we have to obtain these constant value from the given initial condition, which are already given in the question and discussed by we in this part, in this relation. These are the initial condition. These 4 initial condition and the 5th one is this. So now we put x equal to 0, u equal to 0 in above equation. So this 0 is equal to c1 c3 cos of k2 of y, c4 sin of k2 of y into c5 e to power minus c square k square t. This implies that c1 is 0, since c3 cos of k2 of y plus c4 sin of k2 of y is not equal to 0 and c5 e to power minus c square k square t is not equal to 0. So क्यों? क्योंकि x की वैल्यू 0 है. We have substitute the value of x. So c3 c4 is the combination of the function with respect to y, and c5 constant is combination with respect to t. So c1 is 0. Okay, again we put y equal to 0, u equal to 0 in above equation. 0 is equal to c1 cos of k1x, c2 of sin of k1x into c3 into c5 e to power c square k square t. This implies that c3 is 0, since c1 cos of k1x, c2 sin of k1x is equal to 0 and c5 e to power c square kt is not equal to 0 and is not equal to 0. Condition is same. Since here we put the value of x, so c1 is 0. Here we put y equal to 0, so c3 is 0. Now put c3 and c1 in equation 4. We have u of x comma y comma t, this be equal to c2 of sin of k1 of x into c4 sin of k2 of y into c5 e to power minus c square k square t. This be equation number 5. Now we put another initial condition, that is x equal to a, u equal to 0 in above equation. This 0 is equal to c2 sin of k1 of a, c4 sin of k2 of y, c5 e to power minus of c square k square t. Product of these three terms is 0. So this implies that sin of k1 of a equal to 0. क्यों? क्योंकि c2, if c2 will be 0, then the solution will be trivial, and c4 sin k2y is not equal to 0 because we have substituted the value of x, and similarly t is not equal to 0. So this will be sin of n pi. This implies that k1 of a is equal to n pi. This implies k1 is equal to n pi by a. This is the relation of k1. This is the value of k1. Now we put y equal to b, u equal to 0 in equation 5. So we have 0 is equal to c2 sine of k1 of x into c4 sine of k2 of b, c5 e to power c square k square t. So this implies that sine of k2 of b is equal to 0. Same as above. c2 sine of k1x is not equal to 0 because we have to substitute the value of y. So this is the function of x, and similarly t, that is the part of the function of t. So these two terms is not equal to 0, and if c4 is 0, then the solution will be trivial. So c4 is also not equal to 0. So this implies that sine of n pi. This implies that k2 of b is equal to n pi. This implies that k2 is equal to this n, here we take an n, so this we take m. That seems like different, m pi by b. To represent only this different, here n is varies from 0, 1, 2 and so on. Here also m is varies from 0, 1, 2 and so on. Both are variation are same, but it is not clear which will be the value of n. It may be possible in this case we will take m equal to 1, and in this case m equal to 2. So to represent only difference in these two terms, we have taken here n, and here we take m. So using these term in equation 5, we have u of x comma y comma t is equal to c2 c4 c5 sine of n pi x by a into sine of n m pi by b y into e to power minus of c square k square t. All right, this will be the equation number 6. Now we put last initial condition in above equation. We have last initial condition, that is when t equal to 0, u is equal to fx comma y. We have f of x y is equal to c2 c4 c5 sine of n pi by ax sine of n pi by by into, when t is 0, e ka power 0, that is 1. That is so. See this question. In this part, we see that this is the same as the Fourier series for double integration. Fourier series of double integration. So we can write it, this fxy is equal to since the above equation, since the above equation behaves like double Fourier series show C2, C4, C5 this be equal to 2 upon A, 2 upon B, integration from x equal to 0 to A, integration from y equal to 0 to B, f of xy into sine of n pi by a x into sine of n pi by b y m pi into dx dy. This is the value of C2, C4 and C5. This value of C2, C4, C5 can be evaluated by using the double integration process when the value of fxy is given. In this question, fxy is not specific. This is the any general function of f of x and y. So we can left this value of C2, C4, C5 in this equation form. This will be the equation number 7. So, show the complete solution of the given partial differential equation is u of x comma y comma d is equal to summation of C2, C4, C5 sine of n pi x by a into sine of m pi y by b into e to power minus of c square n square upon a square m square upon b square pi t. This is the complete solution where C2, C4, C5 is given in equation 7 like this. C2, C4, C5 is equal to 2 upon A, 2 upon B, 0 to A, y equal to 0 to b, fxy sin n pi x into sine of m pi by b y dx dy. This is the value of C2, C4 and C5. Whenever the value of fxy is given, we use the double integration method and we obtain the solution of C2, C4 and C5, that is unknown constant. इसकी वैल्यू हम obtain कर लेंगे, वो यहाँ पर substitute कर देंगे. And this summation we represent only for representation like Fourier series, because in Fourier series we already know fx is equal to summation of bn sine of nx. So this summation represent for this combination of bn. So this constant C2, C4, C5 is represent a combination of a constant, that is bn, and so to represent this can be obtained by the Fourier series. We use this summation. So this is the complete process of solving this type of equation. One more thing here I want to mention, that whenever we have the case in the given problem for steady state, so whenever we have the case steady state, that is del u over del t is 0. So whenever del u over del t is 0, this equation 1 behaves like del 2u over del x square plus del 2u over del y square is equal to 0. This is the case of Laplace equation. So this problem can be solved by using the process of Laplace equation. So this is very important, that when we solving two-dimensional heat equation, that is the function of three variable x, y and t. But whenever two-dimensional heat equation is the case of steady state, that equation belongs to Laplace equation. So Laplace equation is a special case of two-dimensional heat equation. Laplace equation is the two-dimensional heat equation. So this is the process of to solve two-dimensional heat equation. How we will be take the case of one-dimensional heat equation or two-dimensional heat equation? So we read the question. When the question is the distribution of temperature in a rod, that question belongs to the part of one-dimensional heat equation. And when that temperature is processed through the plate, like plate that is or rectangular or square and something else, that consideration will be behaves like two-dimensional case, two-dimensional heat equation. And in two-dimensional heat equation, we already known in one side of the equation with respect to t, that is first order, and with respect to dimensionally, that is x and y, that is the two second order, that is del 2 of x over del x square, del 2 of u over del y square. So in this way we can differentiate these equations and we obtain the required result. Okay, and then we will be discussed in the next video how we will be use this type of application of partial differential equation and how we can solve Laplace equation. We will be more see about this. Okay, thank you.